All right, greeting folks. Welcome back to another video. And I kind of wanted to polish up the problem that I worked on the last video. The last video was pretty, I would say pretty expansive because we covered a lot about like the nature of logic. We kind of dived into some philosophical waters or philosophical territory, and that's really a way of zooming out and trying to see the larger map and realizing that logic and rationality is only one of many branches of philosophy. There's also a philosophy of science, there's even a philosophy of mathematics. And so I find it really fascinating to dive into those subjects. I think it's very valuable to dive into those subjects. I know it's very valuable to me. Hopefully, it's valuable to whoever ends up watching these videos. For all I know, it could be someone in the far distant future, presuming we still have the internet in like 100 or 1,000 years. And so maybe this could be used for an archaeologist or something like that. And an anthropologist can look at this and say, wow, look at this young person here, explaining their reasoning of these really foundational scientific tools. Oh my goodness. Point I wanted to say for this video is that I wanted to kind of work through that problem again, and this time actually look at the solution. I think it would be really helpful to not only work through the problem, but also look at the solution. Now, and I think I have time to do that. So here's the problem. And there's an A and B, and the statements here are saying use logical equivalences. If P then Q, if and only if, not P or Q, and P if and only if Q is equivalent to not P or Q and not Q or P. And basically, if you want to write the original statement, which is if P then Q, without using the formal symbol of if then, we're going to get rid of it, and we're going to instead use basically the not and the or logical statements rather than the if or then logical statement or the if and only if logical statements. So that's the first part. And then the second part is similar. Use this logical equivalence, which is P or Q is equivalent to not P and not Q, to rewrite each statement form using only and not. So the idea there is that we're getting rid of the or equivalent. And so that should be relatively straightforward. We did it. I felt like I kind of rushed through it, and I didn't feel like I fully understood it myself. So I'm basically going to try again. And you can ignore this part because that part was just like me trying to make sense as to why if-then statement, logical statement or logical operator is equivalent to not P or R in this case. But here's the problem statement that I want to modify. And it basically says if A then R is equivalent to B, if B then R. Right? Or if A then R, if and only if B then R, right? So two kind of like two substatements inside a larger statement. And now we're going to use this equivalence, this one here, and this one here to transform the whole thing. And so the first thing I'm going to do is I'm going to use this second statement. I'm actually going to copy it. And then I'm going to go ahead and paste it right over here. Basically say equivalence to use. And make sure I can delete this. And so that's what I kind of was doing, right? And I just want to polish it, basically. So basically, P equals to if A then R, Q equals to if B then R. And so, I'm basically substituting P and Q with A, if A then R. That's basically what I'm doing. And that's what we're going to go ahead and do. So this here is P. This is this P there. This is Q, which is this Q here. This is another Q, and then this is another A, or another P rather. A, R, like so. Okay, and just like that, we have now transformed it. So that's the first layer of transformation. Now, I think our goal for the first problem is to get rid of the if-then statements and only and the if and only if statements. Or I keep calling them statements, but I mean operators. And so if we look at this, I'm going to go ahead and delete this second one. So this is P, Q, Q, P basically. We just have to get rid of the, we got rid of the if and only if operator. We got rid of this one. But now we just want to get rid of, so basically getting rid of operator. And now for the second step is getting rid of the if and if-then operator. And we can now use this statement here, this logical equivalence. Equivalence to use. And we're going to get rid of the and operator. I'll put a plus there suggesting that we got rid of and that, and the if and only if operator. Okay, so I'm just going to copy and paste this, and I'm just going to substitute this time, A equals P, and Q equals R. That's all we're doing here. A equals P, Q equals R. Or A equals P, yeah, Q equals R. Oh, A actually, it's A comma B. It's going to equal to P, and then Q equals R. That's what we're doing. So let's see. Here's an example of P, if P, then Q. And so this will be P, then there's a not there, and then that would be R. Okay. Same thing here. This is going to be not B or R. And then same thing here, not B or R. And then this will be not A or R, like that. So pretty simple replacement. All right, so that's this is basically solution to A. And then now solution to B is use the logical equivalence, this, to rewrite each statement form using only and not. So new equivalence to use, and in this case, not A and not B are equal to P, and then, oh my gosh, we have so many nots. And then Q, or R equals Q, basically. This should be R equals Q, like so. Technically, I should do P equals A comma B, and then Q equals R. Here, it's a little different. A, not A, because I mean, look, you can look at this statement here. There's a not A, there's a not B, not B, not A. They're going to equal to P, and then Q still going to be R. And so let's update it. Getting rid of and, basically. And we have a lot of ands to get rid of, frankly. So I'm going to do the first layer. I'm thinking, we'll go ahead and simplify in advance. We're going to simplify knots. And so this is basically going to be A or not R, not B not R, we still need the double brackets parentheses, and B not R B not R, and then or not A. Yeah, not A or R, basically. Okay. And so yeah, that actually sort of changes it. Now we have P equals not A, not B, or A or B, and then Q can equal R or not R. And it kind of depends on, depends on which example we're using, because all 4 examples are technically different, right? They're slightly different. This is A not R, this is not B R, this is B not R, and this is not A R, right? So there's four combinations there, basically. The only combination that isn't there is not A and not R. All right, so starting with the first one, it's going to be another layer of parentheses, or maybe just one. Yeah, there's just one. It's going to be not. Oh man, is that right? Why don't they why don't they throw the not in there? Like, am I even allowed to do that? Oof. I guess we won't simplify the knots because I don't want to risk getting the answer wrong. So let's just leave it as it was before. Yeah. Okay. We're going to simplify ands, or simplify or. So first parentheses, it's going to be not, parentheses, not again, parentheses, not, oh my gosh, there's so many nots. Not A, because P equals to not A, right? Not A, and not R. Is that right? I think that's right. So not A and not R. And then, yeah, that's the not. And then there's the original not right there. Yep. Okay. Or pretty much the same mess, except one layer less deep. One layer less deep, except this time it's going to be B. So it's not B. It's not B, right? It's not B because it's not P. And then there's another not here, which goes on the outside. And then that's it. Okay. And This time it's going to be like this one, except there is one more layer of not. I'm pretty sure I need a third parentheses here. Like, if this was programming, man, this would be so messy. I guess we don't need this one. One, two, three. I think I need a parentheses right there. Very confusing, very confusing. No, I don't. I take that back. 1, 2, yeah, we're good. We're good there. This one, oh, I guess I didn't need to add that third parentheses. I'll be right back. Thank you for your patience there. Cooking up some lentils. I just want to make sure these parentheses are right. For the sake of time, I'm pretty sure I'm gonna have to wrap it up pretty soon. I'm trying to finish this. Okay, I don't need this parentheses there. Okay. Right, okay. And then we've got this freaking mess. What a mess. Huge mess. I guess I can get rid of this parentheses. Oh, we'll save it till the end. And then we finally have this here. Right there. And it's going to be, I think an OR goes right here. Like so. So we can actually get rid of a layer here. Yeah, okay. So simplify, so we simplified the first layer, but now we can simplify it again, get rid of these parentheses. Second layer. And so basically, all of this actually, we already have knots. So I'll say this not P equals to that. Not Q is going to equal to all of this. That's the first version. And then there's another version that's going to be similar, except this time not P equals to this, and then not Q equals to this. Yeah, so 4 different combinations. And what we're trying to do is same equivalence to use right here. Right. So what I'm gonna do is just I'm going to plug this in here and plug this in here, and then it's going to be another and then plug this in here again. And now I'm just going to just replace like so. Yeah, we're just going to replace. So here, replace this with this, and then this with this. Yeah. And so I'm pretty sure there's a way to simplify a lot of the knots. Simplify some of the knots. Literally, like detangling knots. And so, for example, I know that not A is just A, right? That's pretty straightforward. Not B is just B. Okay, and then same thing here. Not B is just B. Not A is just A. And let's see if we have we recognize a pattern here. So I see not A, not R, B, R, and then not B, not R, then AR. Okay, I think that makes sense. But now I don't know if, can you like factor in these knots with this and statement is my question. And I think that's a question for ChatGPT. I have about a minute 30 before I wrap up this video. We're so close to being done. But I could try to verify the answer right now. But like, is not A and not R equivalent to A and R? And I'm just kind of like factoring in the knots. Let's see what it says. Because it might not be. No, see, they're not equivalent. It is equivalent to AR, okay. So Morgan's law, yeah, so we have to apply Morgan's law here. If we factor in the knots, we got to flip the symbol, basically, which is kind of interesting. And our goal is to not use any ors, at least for part B. Solution to part B. So I'm gonna ask the ChatGPT is let's post the original statement. Where is it? Here it is. Is equivalent to so solution for to this one, as well as equivalent to all right, let's see. Let's see if these solutions are right. They might not be right. I think they're right. Let's go carefully and formally because there are two different issues mixed together. Oh, okay, so it's right. Excellent. Excellent. I think we got it right. Yeah, yes, your first is equivalent. All right, yeah, nice. Now examine your second one. Incorrect negation. Maybe. Okay, apparently the second one is wrong. Okay. I was trying to simplify these knots. I think it's A R B R equivalent to, let's try this one without simplifying the knots. Oh, you wrote is not equivalent. Dang it. Okay. We were close. I mean, I don't know what I did wrong there exactly. It's really, the whole process is just like cut and paste, really. Looks like we broke the software a bit. We tried to avoid applying De Morgan's law. And so, yeah, I wasn't able to verify if it's right or wrong. I could do it again, and we could certainly try again. But I just wanted to try to shine some light on this, and like just be able to work on this math problem a bit more conceptually. But I think I will stop here. Thank you so much for listening. I hope this was informative. Very complex logical problem. I found it very interesting. I think the level of difficulty is very interesting. I might create a part 3 video, I think, to work on this. But I think for now, we'll leave it at this. Take the loss, just kind of like losing a chess game, basically, and keep learning. Anyways, this is your fellow cloud dynamicist signing off, and hopefully you've learned as much logic as I have. Peace out. Maybe even more.